Here is our first example. Consider the following graph. Step 1 of 2. Does the graph represent a function? Since it is a graph, we will use the vertical line test. So I'm just going to randomly draw some vertical lines on here. And I notice none of my vertical lines are touching the graph in more than one spot. So my answer is yes, this is a function. Step 2 of 2 is to determine the domain and the range of the function. Same graph. When we talk about domain, we read from left to right. So this is a straight line that has a positive slope. It's going upward from left to right. And this is a line that's going to keep going forever and ever and ever. So remember, when I'm reading domain, I'm reading left to right. So it's coming from negative infinity. It's going all the way over to positive infinity. So the domain is all real numbers. When I look at the range, I look at the graph from bottom to top. Again, this graph is extending forever. So it's going from negative infinity down here up to positive infinity. So it is also all real numbers. Next example, consider the following graph. Step 1 of 2. Does the graph represent a function? Here we have a V-shaped graph that opens up. I'm just going to come in here, do what I did in the last graph. Just draw some random vertical lines. If I have a pencil, that's really what I'm usually doing, or a ruler, but I'm demonstrating this for you all. And I notice that none of those lines touch the graph in more than one spot. So yes, this is a function. Step 2 of 2 is, once again, determine the domain and range of the graph. I read my graph from left to right for domain. So this is a V-shaped graph. It's opening upward, so it's going to keep extending forever to the left and right and forever upward. So when I'm looking at the domain, reading from left to right, again, we're going from negative infinity to positive infinity here, which is all real numbers. My range, I read from the bottom to the top. And as I do that, right here is the first time I reach a point that has a y-coordinate. And so that point right there is 0. 0, 0 is my first point. And then it just keeps going to positive infinity. Now, since the point is actually there, I'll come in here and erase that so you can see it. There's actually a point right there, so I'm going to include that 0. It wants our answer to be in interval notation, so my range is going to go from 0 with a bracket to infinity with a parentheses. Question 3, or example 3, match the phrase with its equivalent term. A little vocabulary practice here. What is a set of ordered pairs of real numbers? Our choices are domain, function, range, or relation. And a set of ordered pairs of real numbers is a relation. Here's another problem where we are looking at the graph of a function, and our first step is to determine if the graph is a function. Once again, pop some lines in there, vertical lines. Those lines aren't hitting at any spot more than once on the graph. Basically, it looks like we have a half circle here. So since it's just half a circle, we're going to say yes, it is a function. Step 2 is determining the domain and range. And this graph is very limited in domain and range. Remember, I'm reading left to right for my domain. So this is the area that I'm going to look at between these two vertical lines that I just drew. So that's a 2. And it looks like 8. And there are points there, solid dots. So my domain is going to be 2, 8 with brackets. And when I look at my range, I'm reading bottom to top. So that's going from right there to right there. -10, -9, -8. So -7. up to -4. And again, there are points in both of those places, so my range is going to be with brackets, -7, comma, -4. Here we are evaluating the function. F of -2.2 is going to equal 2 times -2.2 plus 11. 2 times -2.2 is -4.4 plus 11. Gives me F of -2.2 equaling 6.6. Here we have another vocabulary question. If each first coordinate in a relation has a unique corresponding second coordinate, the relation is a range, domain, line, function. And the answer to this one is function. In this question, we're asked to start with a graph and list the ordered pairs corresponding to the points in the graph. And I do this fairly systematically, and I actually read the graph from left to right. I'm going to start with B. B is -3, -7, and you're just counting your points. D is the next point I come to. So if you're not sure about how I'm doing that, I'm just moving over 1, which is my x-coordinate. In this case, I went down to -5, which is my y-coordinate. A, I go over, it looks like 6, and I come down 2, which is -2. C, looks like I'm going over 6, and this time I'm going up 2. So my ordered pairs are 6, -2 for A, -3, -7 for B, 6, 2 for C, and 1, -5 for D. I went ahead and copied over my ordered pairs. Step 2 is to find the domain and the range. And you need to remember that repeated values in a set only need to be included once. Domain are my x values, 6, -3. That's repeated, so I'm not going to write the 6 again, and the next one is a 1. My range are my y values, -2, -7, 2, -5. You could read those off the graph, but if you've got your ordered pairs, just putting that from the ordered pair list works just as well. Step 3 of 3 on this problem is to use the vertical line test to determine whether the graph represents a function. And you really only need to focus where your actual points are. B looks good, D looks good, but you'll notice A and C are on the same line, which means that this is not a function. Here we are evaluating h of -2. Our function is h of x equals 2x cubed plus 3x squared plus 4x plus 3. I'm just going to replace the -2 in that equation and do the math. H of -2 equals 2 times -2 to the third power plus 3 times -2 squared plus 4 times -2 plus 3. 2 times -2 to the third power is -8 plus 3 times -2 squared is 4. And then 4 times -2 is -8 plus 3. 2 times -8 is -16. 3 times 4 is 12. So I have -16 plus 12 minus 8 plus 3. -16 plus 12 is -4. Minus 8 plus 3. -4 minus 8 is -12 plus 3. Negative 12 plus 3 is negative 9. H of negative 2 is equal negative 9. Here we have the same function. H of x equals 2x cubed plus 3x squared plus 4x plus 3. And now we're finding h of 4, which equals 2 times 4 to the third power plus 3 times 4 squared plus 4 times 4 plus 3. 2 times 4 to the third is 64, plus 3 times 4 squared is 16, plus 4 times 4 is 16, plus 3. 2 times 64 is 128, plus 3 times 16 is 48, plus 16 plus 3. 128 plus 48 is 176 plus 16 plus 3. 176 plus 16 is 192 plus 3. 192 plus 3 is 195. H of 4 is equal to 195. Once again, we're looking at a graph to determine whether it represents a function. We have a circle here, and you can see it fails the vertical line test in multiple places, so we do not have a function. We can still determine what the domain and range is, which is what step 2 is asking us to do. Domain, we're looking at our x values, so left to right. This left-hand value is negative 3. The right-hand value is 1. There are points there, so it'll be bracket, negative 3, comma 1, bracket. When you look at your range, you're looking from bottom to top. That is negative 9 on the bottom, negative 5 on top. Again, there are points there, so our range is negative 9, comma, negative 5, close brackets. This question is asking us to find a value for g. G of x is equal to negative 5x squared plus 3x plus 3. And I'm asked to find g of negative 5, which will equal negative 5 times negative 5 squared plus 3 times negative 5 plus 3, which is negative 5 times negative 5 squared is 25. 3 times negative 5 is negative 15 plus 3. Negative 5 times 25 is negative 125 minus 15 plus 3. Negative 125 minus 15 is negative 140 plus 3. Negative 140 plus 3 is negative 137. G of negative 5 is equal to negative 137. We have the same function in this example. G of x equals negative 5x squared plus 3x plus 3. This time we want to know what g of 5 is. So g of 5 equals negative 5 times 5 squared plus 3 times 5 plus 3. Negative 5 times 5 squared is 25. 3 times 5 is 15 plus 3. Negative 5 times 25 is negative 125 plus 15 plus 3. Negative 125 plus 15 is negative 110 plus 3 is negative 107. G of 5 is equal to negative 107. The next problem gives us a relation. The relation is the set of ordered pairs 1, 8, negative 4, 5, negative 1, negative 1, 7, negative 2, negative 8, negative 2, 2, negative 1. Our first step is determine the values in the domain and the range. Enter repeated values only once. The first number in my domain is 1, and then I have a negative 4, negative 1, 7, negative 8, 2. First number in my range is 8, 5, -1, -2, -2, which I already have, and -1, which I already have. So my domain is 1, -4, -1, 7, -8, 2. My range is 8, 5, -1, -2. Step 2 is asking if the relation represents a function. We could look at our ordered pairs to determine that, or we can do the quick vertical line test. And it doesn't look like any of these points are on the same vertical line, so the answer is yes. Here is our next one. Again, we have a graph, and we're asking, or being asked, does the graph represent a function? We're going to do a vertical line test for this, and it is a vertical line. So, big fail there. It is not a function. Our next step is trying to determine what the domain and the range is for this vertical line. When we look at the domain, we're looking at x values, and in this case, there is only one number, and that number happens to be 8. So our domain is just 8. Our range, if you read from bottom to top, this graph keeps going forever in both directions, so it goes from -infinity to infinity, or all real numbers. In this next problem, we have the graph of a parabola, and it's asking, does the graph represent a function? And again, kind of that vertical line test, it passes, so it is a function. Our next step is to determine the domain and the range. Domain, we read from left to right. This graph is going to be opening downward, and it's going to continue forever and ever and ever outward. So it's going to go from -infinity to infinity along the x-axis. So the domain is all real numbers. Now the range, we read from bottom to top. So this graph keeps going down forever, which means that it's down here at -infinity. But as it goes up, it's going to peak right there. And that point is 4. So our range is from -infinity with a parentheses to 4 with a bracket. Here we are evaluating a function again for a particular value. We have f of x equals -2x plus 4, and we are asked to find f of -2. F of -2 equals -2 times -2 plus 4. -2 times -2 is 4, plus 4 is 8. That gives me f of -2 equals 8. Same function, f of x equals -2x plus 4, and this time I'm asked to find f of 3, which is equal to -2 times 3 plus 4. -2 times 3 is -6, plus 4 is -2. The value of f of 3 is -2. This next one is also asking us to consider a function, which is h of x equals x cubed minus 6x, and it's wanting us to find the value of h of -4. H of -4 is going to equal -4 cubed minus 6 times -4. -4 to the third is -64. -6 times 4 is plus 24. -64 plus 24 is -40. H of -4 equals -40. This is the last example we're going to do. It's a two-step problem. The first is asking us to determine if the graph is a function. And we've got lots of places where it's failing that vertical line test, so our answer to that is no. When I'm looking at the domain and range, looks like if I read from left to right, we're going from -infinity to infinity, which means all real numbers. If I look at it from bottom to top, again, looks like -infinity to infinity, so it's all real numbers.